In this video, we're working on how to solve sinusoidal equations. What I'd like you to do is make sure you have some type of graphing calculator with you using Desmos, or you can obviously use your TI-84 plus CE or Inspire, whatever you want. But we're going to go ahead and write down this problem. I'm going to use Desmos simply because I know a lot of my students have access to that. Alright, so right now we're just going to go through the problem solving process. Very, very similar to what you've done all through math as far as solving an equation. We have to isolate this variable x. Alright, so first thing we're going to do is just take away 4 from both sides. And we do this, that zeroes out. We're left with 8 cosine 12x equals negative 8. Then we divide both sides by 8. And we get the cosine of 12 times x equals negative 1. Now, if I had the cosine of x just by itself equals negative 1. And remember, the cosine of x is always the relationship of your x variable, value to your r value in the unit circle. So I'm going to make a quick little unit circle. Hope you guys visualize it just a little bit. Alright, so there's my unit circle. Alright, so in the unit circle, where is the x value negative 1 and the r value a positive 1? Well, that's right here. Right here at negative 1, 0. Right here at 180 degrees, also known as pi radians. I'll put pi rad. We are at negative 1, 0. That's the only point where the cosine of x is equal to negative 1. So when you're solving this and you apply what's called the inverse of cosine to this side and the inverse of cosine to this negative 1, what you're going to get is you're going to get 12x out of this equals, and you're going to get 180 degrees. But I'm going to go ahead and show you in Desmos. We'll go over here. I will go to my little function area. I'll type in the inverse of cosine. I will type in negative 1, and it'll say 180. And that's if you're in degree mode. In rate mode, you're going to see pi. You'll see the approximate value of pi. But here we're in degree mode. All right. So if the question was just, if we didn't have the 12x, then the answer would be 180 degrees. All right. Like, how could I get to this point over and over and over and over again? Well, my answer would be 180 degrees plus 360 degrees times n, where n is an integer. All right. But we can't do that. All right. So my whole answer would be 360 degrees times n. But I have to divide everything here by a 12. So I got to divide everything by a 12. So my answer is not going to be this if we were just solving for x. We're solving for something like what if you had to multiply x by 12. So we're going to have to divide everything by 12. All right, and so 180 divided by 12 is 15. And this will be 30 degrees times the value of n. All right, so what we're going to do, and n is simply an integer. All right, so understand that basically after I divide everything, I just multiply it by n because that will get us to the same spot over and over and over. So over here, you're going to notice I'm not going to choose the 180 plus n times 360. I'm just going to choose 15 plus 30 degrees times n. 15 degrees plus 30 times n. All right, so if you miss one of these, you can certainly go to see a step-by-step solution, all right? And they will show you, again, basically all we did right here was subtract 4, divide by 8, take the inverse, and the only solution that would work every single time would be this one. All right, let's go and do another one. All right, on this one it says, select one or more expressions that together represent all the solutions to the equation. Your answer should be in degrees. Here's our equation that we're going to solve. All right, so let's go ahead, start working through it. First thing we're going to do is just going to take away 6 from both sides. That zeroes out. We're left with 3. So now we have 5 cosine 6x equals 3. All right, now we're going to divide both sides by 5. And we're left with cosine of 6x equals 3/5. And this is where you're going to have to apply the inverse of cosine on both sides. Inverse of cosine on this side, inverse of cosine on this side, and you're going to get 6x equals whatever this approximate value for the inverse of cosine is. Since we already have a inverse of cosine, put 3 divided by 5, we get 53.13 degrees. 53.153, say 0.13 degrees. Now we got to think about, where would cosine be positive? All right. So in the unit circle, if we're making our unit circle, where could I have a positive cosine? Well, cosine, all right, my x values are positive in the first quadrant and also in the fourth quadrant. That's where our x values are positive. So if I wanted to make a 53-degree angle, and I'm just estimating right about there, I could make a 53-degree angle right here, and my x value is positive. And I could also make a 53-degree angle right here. But we call this positive 53 degrees. From here to here, we call it negative. So right now, I'm going to say this could be actually plus or minus 53.13 degrees. And then from there, what would I have to do? I could add 360 degrees to this over and over again, and then multiply it by an integer. So when I divide everything by 6, I'm going to take that into consideration. So all I'm going to do is I'm going to take this 53.13 divided by 6, and I get 8.855. Alright, so I'm going to say x equals plus or minus 8.86 degrees, and then 360 divided by 6 is 60, so I'll put 60 degrees times my value of n. So I'm going to have a plus or a minus in this case, because plus will get me here, minus will get me right here, and then that 360 divided by 6, because we had to divide both sides by 6, will give me that 60 times n. So I'm going to choose a plus and a minus this time. I'm going to choose this minus, and I'll choose this plus, and that should get me to those areas over and over and over again. All right, let's do another one. This one also is in degrees. So we have 4 cosine 10x plus 2 equals 2. All right. Once again, first thing I'm going to do is going to take away a 2 from both sides. Get 4 cosine 10x equals 0. That zeroes out. That zeroes out. All right, then we'll just divide both sides by 4. And we get cosine of 10x equals 0. Well, let's think about this. Where would the cosine of just x or would the cosine of x equal 0? When is the x value 0 over 1? That's what you want to be thinking about. So if you had a unit circle, there's only one area in the unit circle where the x value, actually there's two areas where the x value is equal to 0. Alright? One is right up here where we have a 0 and a 1, and one is right down here where we have a 0 and a negative 1. And this puts me right up here at 90 degrees. Alright? And this is 270, but we can also call this negative 90 degrees. And that's where the x value ends up being, like this is your x value, this is your r value on the unit circle, because we're dealing with cosine. Cosine is x over r. Sine is y over r, but cosine is x over r. So if I do the inverse of cosine on this side, alright, and over here I'll erase it, make it a little bit neater. Do the inverse of cosine on this side, we will get 10x equals 90. Alright? So we will get 90 degrees. But from the unit circle, we can see that it could be 90 degrees, but we could also have negative 90 degrees. That's when the 0 over 1 or 0 over negative 1, it's still 0. So I'm going to say this is going to be plus or minus 90, because that could get us here or here. Alright? And then I'm going to add 360 degrees to that over and over and over again. But then when we divide everything by 10, alright, our final answer will be x equals plus or minus 9 degrees plus, now 360 divided by 10 is 36 degrees. I'm going to say times n, and that'll do the plus or the minus. So I'm going to choose answer choice C and D. Alright. Ooh, you're good. We got one in ratings. Excellent. We got one in ratings. Let's go ahead and do this. Alright. And for our last problem, here we go. We have 9 times the sine of 18x plus 11 equals 2. First step, you know, subtract 11 from both sides. We have 9 sine 18x equals 2 minus 11, which is negative 9. Then we divide both sides by 9. And we get the sine 18 times x equals negative 1. So when you're looking at the unit circle over here, where am I going to get if the sine of x just by itself equals my y value over my r value? Alright, the sine of, I'll put theta so you're not thinking about just the sine of theta being the angle is y over r. Where's the y value negative 1 and the r value positive 1 on the unit circle? Well, there's only one place where that happens. That happens right here. That's when the y value right here is negative 1, and the r value being the radius, is also a positive 1. So we're only going to be worried about 1 point right here on this one, not 2 points, because there's only one time you can get to a negative 1 for the y value. Okay? So, if I take the inverse of sine on this side, and I take the inverse of sine on the other side, and this is a negative 1, alright, you're going to get 18x, because these cancel out, equals negative 90 degrees. But in radians, what is negative 90 degrees in radians? Well, that's going to be negative pi over 2. Now, if you didn't know how to do that, you could take negative 90, and you could multiply it by pi over 180, and negative 90 is negative half of 180, so you're left with negative pi over 2. So, over here, I'll go and delete this real quick. This makes it very, very easy. You can kind of see the difference. Functions, inverse of sine, right there. Type in negative 90, not negative 90, negative 1, we get negative 90. If you switch that to radians, you get this number. But this number right here is technically negative pi divided by 2. Think about it. If you double that, it gets really close to negative 3.14, which is your approximate value for pi. So we have negative pi over 2 is this negative 1.57. All right? So if we were going to do the answer in degrees, we would say x equals negative 90 degrees plus 360 degrees times the value of n. But if we were going to do this before we divide everything by 18, if we were going to do this in radians, we're going to say it's going to be at negative pi over 2 radians. All right? Plus, now what's 360 in radians? 2 pi times n. And that's what our answer would be before we had to divide everything by 18. So now all I'm going to do is take this approximate value and this approximate value and divide everything by 18 to get our answer. And we're going to do that over here in the calculator. All right, so we're going to take this, and I'm going to say divide that by 18, and I get negative 0.08. All right, negative 0.0. We'll put 0.9. All right, plus. Now, I'm also going to do 2 pi all divided by 18 and get 0.35. N. Let's see if we find something. Maybe we do, maybe we don't. Maybe we'll find it. Okay. Oh, never mind. They left it in. They have in decimal. They left it in fraction form. Well, that makes it a little bit easier. Okay. So right now, if we divide this by 18, that'll be negative pi over 36, and this simplifies to pi over 9 times n. Okay, that makes it a little bit easier to work with versus decimals. I like that. Should have noticed that a little bit earlier, but I didn't. All right, so right now it looks like the answer that I'm going to choose, just one answer, because there's only one area that can get us to a negative 1 right here. All right, and that's going to be answer choice B right there. All right. Now, if you're wondering what did I do to get to this 36, I took negative pi over 2, and I divided it by 18, which is basically multiplying it by the reciprocal of 1 over 18, and that's how I got negative pi over 36. Okay. All right. Let's see here. Go back over here. Got negative pi over 36 times n pi. There you go. And that's your final answer. Hope this video was helpful, and just kind of think about, are you going to have a situation where you're going to end up having just one answer? You're going to have a situation where you're going to end up having 2 different answers. Okay? Y'all have a good day.